We are about to explore one of the most fascinating and mysterious worlds in our solar system, Jupiter's moon Europa, a frozen sphere hiding a global ocean beneath its surface. Join me as we dive into everything science knows and suspects about this extraordinary moon. Europa is not Jupiter's largest moon, nor the brightest, nor the most chaotic. Yet it stands out as the most promising place to search for extraterrestrial life close to Earth. Scientists believe that beneath its icy shell lies an ocean deeper than any on Earth. Europa's surface resembles a fractured shell of ice. Dark streaks cross the terrain in chaotic patterns, evidence of stress, shifting plates, and internal forces reshaping the moon. Below this frozen shell is the true wonder, a vast global ocean. Estimates suggest it may contain more water than all of Earth's oceans combined. This ocean is in permanent darkness, but warmed by internal heat generated deep within Europa. How do we know this ocean exists if we have never drilled through the ice? Magnetic readings from the Galileo spacecraft revealed that something electrically conductive, likely salty liquid water, responds to Jupiter's magnetic field. This was the first major clue. There is more. Observations from the Hubble Space Telescope suggest that plumes of water vapor occasionally erupt from the surface, possibly leaking from pockets of liquid water within or below the ice crust. Europa is exposed to powerful radiation belts created by Jupiter. This radiation constantly bombards the surface, breaking molecules apart. Ironically, this destructive process may help feed the chemistry of life if oxidants are pulled downward into the ocean. Europa's internal heat comes from tidal forces. As Jupiter's intense gravity squeezes and stretches the moon, friction generates heat inside. This keeps the subsurface ocean liquid and may create hydrothermal vents on the ocean floor. On Earth, we find organisms living around hydrothermal vents in completely dark, oxygen-poor environments. These creatures survive using chemical energy from mineral-rich fluids. If similar vents exist in Europa, life could emerge or survive in its abyss. Imagine an endless ocean, pitch black and ancient, filled with chemicals, minerals, heat sources, and perhaps biological activity. Microbial life could thrive, maybe even more complex forms if energy is abundant. Europa was discovered by Galileo Galilei in 1610, but its potential remained unknown until the space age. The Voyager flybys revealed its icy surface. Galileo's detailed study in the 1990s changed everything by confirming the strong possibility of a subsurface ocean. Galileo detected shifting ice plates, mineral compounds, magnetic anomalies, and the lack of large impact craters, all pointing to an active, renewing surface and warm internal layers. One of the greatest unknowns is the thickness of Europa's ice shell. It may be just a few kilometers or dozens. A thin shell would make future drilling missions easier, but a thick one would require advanced technology. The upcoming Europa Clipper mission will orbit Jupiter and perform dozens of close flybys of Europa. It will scan the surface, analyze plumes, map the ice, and search for chemistry related to life. The spacecraft will measure the composition of the surface and subsurface, study heat patterns, detect water reservoirs within the ice, and look for organic molecules that might originate from the hidden ocean. The European Space Agency's JUICE mission is also exploring Jupiter's icy moons. Combined with the Clipper, these missions will create the most detailed understanding of Europa ever achieved. Landing on Europa is possible, but extremely difficult. Radiation would rapidly damage electronics. Any lander would need shielding and a short operational timeline to gather as much data as possible before failing. The dream is to send a cryobot, a probe capable of melting its way through the ice until reaching the ocean. It could release a submarine drone to explore the depths. While technically far beyond current capability, research continues. If humans send a probe into Europa's ocean, contamination becomes a serious issue. We must avoid transporting Earth microbes that could destroy or alter native ecosystems. Planetary protection rules are essential. Europa is smaller than Earth's moon, but its geology is far more active. The temperature at the surface can drop to minus 160 degrees Celsius. Its ice shell may move, crack, and melt beneath the forces of Jupiter. Europa offers a natural laboratory to test a profound question. If life can arise independently in two places within the same solar system, then the universe is likely full of life. The confirmation of extraterrestrial life, even microscopic, would fundamentally reshape our philosophies, sciences, religions, and understanding of our own place in the cosmos. In the coming decades, robots may dive into Europa's ocean and reveal ecosystems that have remained hidden for billions of years. This could be the greatest discovery in human history. Europa remains a world of secrets, but every mission and every discovery brings us closer to understanding whether we are truly alone or part of a universe filled with life. Thank you for watching. If you love science, exploration, and cosmic mysteries, make sure to follow our channel for more documentaries like this.